Welcome back to our object-oriented programming course in Python for biologists. Today we're going to look at file input-output. That is how to read files, how to access data if it's already on your computer. And then if you afterwards do some, say, graphs or other data manipulation, how to then write the information back onto your computer. What I'm probably going to do today is ask my students their more general thoughts about files or see what they know. So the questions I ask them will probably be kind of on the broad side. What's that? Here we go. As usual, let me ask about 10 people. And to pat myself on the back, I did a better job of shuffling and then alphabetizing the names, so hopefully it'll be a little easier for you to find yourself. Go ahead and, if your name is there, go ahead and give us a glimpse into your computer tidy and organization. Alright, so as the folks are finishing up here, it looks like we have some similar strategies. You all being students at a university, you have separate folders for each class, keeping them organized. You might be mindful of the dates of the files, might be the download date or the last time you saved a file. You might change the file name to specifically coincide with the assignment. These are all great ideas. Okay, so thank you all for giving us a glimpse of your organization techniques. We'll dive into some Python now. So like usual, I'm going to open up Anaconda. Later in the semester, when the code is more hectic, more involved, I'll probably have some template files available for us so that we don't always have to start from scratch. But for now, just maybe a couple more times we'll start at the beginning. I typed in Anaconda into my search bar or finder. It brings up this Anaconda Navigator. we're gonna go into Jupyter Lab. When I closed my old work, it brings up this launcher that allows me to quickly press the button for Python 3. I forgot if I mentioned there are historical reasons why you might hear about Python 2 or Python 3. Suffice to say, Python 3 has been accepted by most places by now, so you should be fine if we only deal with Python 3. Now, today's set of notes is called File I/O, or File Input Output. At the moment, I just want to put a nice title on the top of my notes here. But if I run this, I'm going to get an error, and this different color for the word "and" was kind of a hint that, oh, I accidentally treated this as Python code when I wanted this first code block to be Markdown. So now it appears more naturally as a Markdown block. Part of what makes the process of loading a file into your coding session is that there are these different items that we need to consider, and we'll walk through it today. That the notion of file name, file handler, and file contents are all different. Maybe I should attempt to explain this in terms of an analogy. Think of if you ordered something through the mail and it comes in a cardboard box. Where we ended up last time is I just quickly shoved in the notion of how to stay organized. And I recommend at the moment for this class that if we have multiple files to deal with, that we keep them all in our Bio 184 folder. So here I have my Bio 184 folder on the desktop, and when I open it, I have the current Python notebook that's here, and we're gonna also be trying out a couple of different data files. Rather than worrying about having to find them in the computer, let's just keep them all in the same place for now. And if you're more interested in more complicated ways of organizing your files, feel free to ask during office hours or discussion section. Since I'm in Jupyter Lab, we could also see that I have these three files in the same place because the lab file viewer tells me so. So what I want to do is eventually load up this text file called load this. If for some reason we need to refer to this string in more than one place, it's going to be useful to give it a name, kind of an extra label. And also, I like to use verbose variable names that makes the code easier to read later on. Also recall that your variable names cannot have spaces in them. So when I do want something that functions like a space, I tend to use underscores. There are a few steps in this process. Fortunately, the folks who made Python made this relatively straightforward. We're going to use the open command to open a file. And notice that we put the file name inside the parentheses. Now, to get a look at what's going on in the background, let's go ahead and see what file handler is, at least in terms of the computer parlance or the software itself. So we have some obscure names here. We could see that we're still pointed at something called loadthis.txt. We'll look at this mode in just a few minutes. And just to briefly explain this last part, in terms of computers and how they were made in different countries and whatnot, just like spoken languages, internally computers could have slightly different languages as well. So there are issues like, is a question mark in an American computer the same as a question mark in a French computer, etc., etc. So there's a notion called encoding that you might encounter. But if everything's encoded the same way, then the communication should flow nicely. In particular, I'm going to look at the type of variable or structure that we're invoking here with the file handler, and then furthermore printing that to the output. Later in the semester, we're going to deal with something called classes. But for now, this file handler is not just a number, not just a word, not just a string. It is something special called an I/O text I/O wrapper. You probably figured by now I/O stands for input and output. But for the most part, hopefully it sort of makes sense that the file handler tries to take care of the work for us to try to bring in the information nicely into our coding session. But the file handler is like the delivery person. They just bring the box to the door. They don't open that box for you. So to actually read the contents, we're going to tack on this read function to the file handler. So now here in my Jupyter coding session, I have something saved into something called file contents. And to see what that is, let's go ahead and wrap that in its own print statement. And this information appeared. And where this information came from was the loadthis.txt. If I, here on Windows, load that manually, then that's my text document there. OMG, this worked. Due to how this material might be brand new to you, I'm going to ask questions in a pretty broad sense. I'm going to ask another 10 people. What do you know about file extensions, if anything? So if you see your name there, go ahead and let myself and the discussion section leader know where you are on this material. Okay, so while people are finishing up here, we have a variety of answers, understandably. I'll come back to the Google Doc in just a second. The file extensions, most straightforward view, as you can see on the left hand side here in my file viewer, the file extensions are what appears after the last period. So here on the first one, it's .html. HTML is the file extension. Here on the second line, we see .ipynb. IPYNB is the file extension. As Samuel pointed out, depending on the type of file, when you open it, your computer will probably handle that with a different program. Like maybe Safari or your internet browser will open up. Or with a doc file, perhaps Microsoft Word will open up. Something like that. As Elizabeth mentioned, we could have various file types for different data types, whether it's a document, a picture, maybe a sound file, a music file. And another place you've seen this is in my classes when I dictate something like, oh, you have to submit the homework as an HTML file. We are using that to eventually make it easy for us to grade your work if the files are in the same format. And thus, I might have told you earlier in the semester to make sure that your computer is set up so that you could see the file extensions. You could see this information after the last period, and that will help us with the organization and to be able to keep, the information organized. Something that it's not quite obvious, and I myself could forget to do this at times. Because we had opened a file, it's a good idea to close the file. I cannot think of a clear analogy off the top of my head, but it's just good for your computer that you close files that you are not using at the moment. And for example, here, this code will load the information out of the file loadthis.txt. Now I have that information, this silly string, OMG, this worked, here in the coding session, but I don't necessarily need the original file open anymore. So I could just put that away and store it away. This somewhat helps avoid accidentally corrupting files with other information or accidentally overwriting or saving over a file as well. Another place you probably heard this is if you're using an internet browser such as Chrome or Firefox. If we make a lot of tabs, eventually it gets to a point when the computer would slow down because it's trying to handle everything at once. So you've probably heard the advice that every once in a while you should clean up your tabs and your computer will perform better. It's kind of the same deal here. Close the files when they're no longer needed, and then your computer can concentrate on what you're trying to do. If you thought that last question was tough, here's an even tougher one for these 10 students here. So go ahead and go for it. All right, so we have some substantial answers here, and as your colleagues have said, it's the notion of who could perhaps edit a file, who has access, or in other words, you could restrict access to a file if need be. Something I think I have on the present homework assignment is asking you to practice what is concatenation of strings. That is combining two strings together. So remember, file contents was back here, having read information from the file. We printed the file contents, which was this string. OMG, this worked. And now I want to tack on another clause that says, and I want to learn more. So think to yourself, what will this output look like? So we have a awkward exclamation point in the middle. We could get rid of it, but at the moment I simply wish to remind you that if you want a space, say before the word and, remember that you have to explicitly put the space inside the string as well, somewhere inside the string. So now the space appears. And a very useful skill is after you do some work with computer coding, say if you do a data analysis, create an output file of the data so that you could send that to your teammates, your collaborators. Now, similarly to loading a file, there are different things to consider. In this case, it's like, okay, now I have to get a box. Now I have to take the box to the post office. And there's something inside the box. Now I'm going to give this file a new name in that notice this results.txt at the moment does not show up on the left hand file viewer pane. This results.txt does not exist yet. So what this is doing is kind of creating a blank canvas. And we'll elaborate on this W in just a second, but let me leave a comment here. So now when I run this line of code, notice that the results.txt is now in my Bio184 folder. That is in the same place as this Python notebook. I'm not sure if I could open this yet. Results.txt is in my Bio184 folder. And at the moment, there's nothing in there. There are no results yet, that is. And thus, to write something in the results file, we use the write command. Now, something along the way that happens here is that, say if I'm still going with my analogy about the delivery drivers, there was some internal codes on making sure that the delivery worked out correctly and whatnot. And also having to deal with the permissions and access. So while we put this string in the results.txt file, some computer mumbo jumbo might appear here. And thus an actual error shows up. You probably do not have to worry about this right now. So let's go ahead and go back and check that Bio184 folder. I have my results.txt. I try to open it up. The information's not there. Something went wrong. So, in other words, let's say for the hypothetical, I sent this file, or I wanted to send this file to the discussion section leader, Akshay. I said, here are my results. Hey, Akshay, read over this. However, at the moment, there's nothing here. What I'm missing is I have to close the file. It's a little more necessary this time around. In other words, I was trying to show the file to Akshay, but the computer was like, but Derek, you were still writing in it. So the file could not be in two places at once. Now that I properly closed the file, let's see if this works now. I go to my Bio184 folder. This results.txt, I could see by the file size has something in it now. And now the desired information is inside that file. I'm going to take a soda break here. But if you have any questions, feel free to ask them in the Twitch chat. All right, moving along. The sample of students surprised me. We had a good response to the file permissions. This is something you might have thought of before, and that was on me for assuming that you did not know. The notion of file permissions in the history of computer science goes back many decades. So if this is one of those, if it isn't broken, don't fix it type of deals. The ones that we'll be considering are called read, write, or read, write. As you can imagine, the read permission gives the viewer only the ability to read the information. they cannot um, adjust the data, they cannot type in there or whatnot. Analogously speaking, this is kind of like when you rent a textbook and you realize throughout the semester that you do not want to write in it because you're going to try to sell the textbook later. It's kind of the analogy. Moreover, part of just file organization and staying organized is whenever you receive data, you should leave the original data set alone. So it might be a good idea to only read the information, do your calculations and analyses elsewhere, but leaving the original file uncorrupted. For the write, let me just insert this thought for a moment. It means to start a new file and start writing. In contrast, the append ability gives us the ability to add information to a previously made file. So what happens is that sometimes, say if you're working on a team and you most likely do not want to accidentally delete something someone else had done, well, for yourself, you might want to write a new file. But to make sure that no one else had already used that file name, you would just give it this level, the write permission. And if for some reason a teammate had already started working on that file name, then the computer would let you know. The append ability is more powerful. You could add information to something that was already there, but at the same time, because it's more powerful, you might accidentally delete something that was already there as well. Just out of old habit, I tend to use simpler language such as the word add instead of append, just in case the word append is brand new to people. Like it was to me when I started learning this stuff. So I'm going to take that results.txt file. That was this file here where I had inserted the sentence. This should be in the output file. And I'm going to specifically give this a append permission. Give myself permission to add to the file. To be organized, I'm going to put the \n here. I want you to think to yourself for about 10 seconds. Do you remember what \n does? The folks in chat are correct. That was called a new line character. Literally starting on the next line to add information. I'm going to invoke the .write function again. And we could just do this over and over again, writing more and more lines of information, which is something we'll get to pretty quickly in the homework. I know the phrases I'm choosing for this example are kind of boring, but this is actually how I learned computer programming, is to like put very specific information in certain places so I can make sure that it's showing up where I want it to be. Some internal data was leaked in the process, but what I intended at the moment was that this phrase, this should also be in the output file, should be in the output file. Go into results.txt in my bio184 folder. I still only have that first phrase. I didn't get the second phrase in there. And you might recall that's because after I had written some things in the file, I forgot to close it. I forgot to close the file. So remember to close the files when you're done with them. Notice that the output actually goes away now. There's nothing for the Python output to say here in Jupyter, because we had put the results, or placed the results, in the results.txt. I happen to had run the code twice, so that's why this is appearing twice. I'm going to take a soda break. If you have any questions, feel free to write them in the Twitch chat. Okay, so I might not phrase this correctly. I'm just kind of doing this off the top of my head here. So our last group gets to take on this broad question. Let's think about the genomics world and what the investigators are dealing with. Remember that this is more of a biology question. So if you're a bio major, I'm asking you more about the biology side of things, not the computer programming side of things. We got some excellent guesses here. Just reading top to bottom. Araceli is talking about maybe bringing in information about genotypes and phenotypes, amongst other suggestions. Dustin mentioned alterations and mutations. Herman mentioned amino acids. And similarly, Yasin mentioned codons. And I'm highlighting some of those because here in Bio 184, yes, we are actually going to talk about some of these different ways that you have already studied DNA in terms of their proteins and their functions and their mutations. And we're going to hopefully be able to show you ways that modern day genomics experts, perhaps geneticists as well, keep track of all these issues. So what I want to do now for the last part of this class is to mention the file type that the DNA information tends to be in. To this day, I actually haven't decided how these words are pronounced. to the best of my knowledge, there are scientists who over the years called these fast A files, fast B files, fast Q files, etc. But when I first started learning this bioinformatics, biogenomics material, I heard this pronounced as FASTA files, and I kind of got used to that, and I think that's true of some of my colleagues as well. In other words, sometimes you'll hear us say FASTA file, and sometimes you'll hear us say FASTA file. Just treat it as being interchangeable, please. The FASTA file is the simplest. It contains the DNA sequence. However, keep in mind that DNA sequences could have thousands, if not millions, of nucleotides. So sometimes we need ways to quickly refer to the sequence. We might have a label, such as, oh, this is a human genome from the North American continent. We might have an abbreviation, such as HG for a human genome. What other files, such as FASTB, bring in is more metadata, such as when and where the DNA was collected. We might be studying genomes that were collected from UC Santa Cruz, for example. UC Santa Cruz has quite a substantial database. Also, there's the notion of quality. Looking at millions of microscopic molecules might have issues with quality and accuracy. So, good investigators will also report where they're pretty sure the nucleotides are correct or where they're making educated guesses. So I have a DNA sequence that's stored in a FASTA file. Let me just, for devil's advocate, if I double click the FASTA file here, my computer, even with like some advanced stuff that I've done on my computer, even my computer is kind of throwing up in errors like, I don't know how to open that yet. I'll show you that software on a later date. But fortunately, here in Python, we could load the information pretty quickly with the steps outlined above. So let's go ahead and print the file context. As you can see, I just have a quick example of a possible DNA sequence. And now that I, once again, have the information saved into file contents, I do not need the original file right now. So go ahead and close the original file. But say if someone came along and asked, hey Derek, what are you working on? And I'm just sitting here going, I don't know, it's kind of fake, dude. I'm going to create a new file. I'm going to give it a different name just so I don't accidentally overwrite, as a failsafe to not overwrite the original file. That has to be in quotation marks. I'm going to explicitly use the write permission for the reasons stated above to not overwrite something that came before to make sure that we're using a new file, etc. And what that did, as at least on the file side, you can see on the left hand that I do have a new file that I called new DNA2. At the moment, I just wanted to apply some really crude metadata to it. I basically said it's fake DNA. And as a quick aside, I actually do have programs that can open this. But for now, all I did was add the label fake DNA in front of the DNA sequence using the skills that we have covered today. Alright, I know that material is kind of dry, but just give me a little bit of feedback on what you were able or not, or still have questions on in the reflection. And once you're done with your reflection, that'll be it for today, and I'll see you on Thursday.